Hello students, this is D.V. Patil. Today we are going to cover our next unit, that is unit number 8. The name of the unit is Standard Template Library. So we will see the examples what is meant by the Standard Template Library in this unit. So in earlier unit we have already covered what is meant by the template. So the reference of the template is required to know or to understand what is standard template library. Okay, so let's start. First, what is meant by the STL? That is nothing but the standard template library. So the standard template library is a set of C++ template classes to provide common programming data structures and functions such as list, stack, arrays, etc. Okay, so it is a library of container, classes, algorithm, and iterators. It is a generalized library, and so its components are parameterized. So in short, STL it is nothing but it is a set of C++ template classes. So nothing, it is nothing but I'll tell you one example that, so in data structure you have solved or you have written the code for the sorting of the algorithm. Okay, so while doing this sorting of the algorithm we are writing the logic that how should be the array, then what should, how it should sort the arrays in ascending or the descending order. Likewise we have to write every logic. But if we are using the standard template library in C++, then we should not worry about the logic or how the elements should be sorted. So if we include some of the library functions, inbuilt library functions, then it will give you automatically, without knowing the code behind the sorting of the elements, it will give you the elements in a sorted order. So that is nothing but the standard template library. Okay, so it is a library of a container, classes, algorithm, and iterators. So these are some of the components of a standard template library, that is nothing but the algorithms, containers, functions, and iterators. So these are the four components. So let's see well one by one. First one is the algorithm. The algorithm defines a collection of functions especially designed to be used on a ranges of the elements. Okay, so as I already told, so algorithms are used in for the functions which are designed to be used on the ranges of the elements. Okay, so they act on the containers and provide means for various operations for the contents of the containers. Okay, these are some of the examples of the algorithms: sorting, searching, then important str algorithms, then array algorithms, and partition operations. Okay, we will see one or two examples from this in next example. Then first we will see the example of the sorting, or what is mean by the sorting. Okay, in algorithm component. So sorting, it is one of the most basic functions applied on the data. It means arranging the data in a particular fashion which can be increasing or decreasing. So we are having the array, and if we apply the sorting algorithm, the array is being sorted in either increasing or decreasing, or ascending or descending order. There is a built-in function in C++ STL, and the name of that function is a sort. Okay, so with the help of this function we can just sort the elements without writing the whole logic for sorting of the elements. Okay, the syntax for the sort is the sort in bracket start address and end address. This start address is from where your array is getting started, and end address is where your array is get ended. So that we have to mention, and that is the only syntax for this. In sorting, it is implemented using hybrid of quick sort, heap sort, and insertion sort. Okay, so when this library for the sorting is being generated, it is implemented using hybrid of quick sort, heap sort, and insertion sort, but by default it generally uses quick sort only. Okay, so we will see one example for the sorting of the elements. Okay, remember that for this we have to include some of the library files, so that's why turbo c will not support for this, so I'm using here dev c++. So let's start a simple program first to sort the elements. Okay, so first hash include iostream.h. Okay, after iostream.h, we sorting is an example for the algorithm components. Okay, so for that's why we have to include one more file related with the stl, that is nothing but the algorithm dot, sorry, dot h is not required here. Okay, algorithm. So these are the two files. So if we will need also hash include conio.h. So these three will be the files or header files. Okay, now what we are going to do, we are going to sort an array. Okay, so first using namespace std. Okay, then I will take main method here. Now in main method, what we are going to do first, so first declare the array of integer type. Suppose integer 10 is equals to, I'll give the elements over here only, 2 3 4 5 6 7 8 9 and 10. So 10 elements I have given over here. Then next, what we will do, we will first display the array. Cout before sorting array is. So we have just displayed the array before sorting the array, and for with the help of the for loop we have just displayed this array, a of I. Okay, now we have to apply the sorting on these elements of the array. So as I told you, the syntax for the sort is sort in bracket start address and end address. Okay, that only we have to mention. So sort is the inbuilt function. We have to just mention from where your array is starting and from where your array is ended. So from a, and it ends at a plus 10th element. Okay, only that much we have to mention, then your array will get sorted over here. So let's see out. I'll just display the message as after sorting your array is. Okay, and l. Again I'll require for loop as equals to 0 as less than 10 I plus plus. Okay, again cout a of I and endl. Here your program is over. Very simple, because your template is already there. We have to just mention the name of the algorithm over here. So we want to sort the elements, so we just what we have done, we have mentioned the name of the function which is included for, or which is used for sorting of the element. That only we have to mention over here. So let's see. First I need to save the file stl1. Okay, so it is getting compiled. Include conio not required. So execute, compile. I will declare here only integer I instead of this. Okay, so it is getting compiled. Then run the program. So you can see here, before sorting array their elements are this, and after sorting it is getting sorted. So only we have just mentioned the name of the function which is used to sort the element, and the syntax for this: sort a and sort in bracket start address and end address. That only we have to mention over here. So this is the first algorithm for the sorting of the elements, or the first example. Now see this, let's see another example from the algorithm, which is nothing but the searching of the elements. So searching, it is a binary search, and it is widely used as searching algorithm that requires the array to be sorted before search is applied. So before doing a search, or before applying the search operation on the array, your array must be in a sorted order. So we have already used this sorting of the elements. Then before searching the elements, we have to sort the array first. So the main idea behind this algorithm, that is searching of the element, is to keep dividing the array in half. Divide and conquer we have to apply until the element is found, or all the elements are exhausted. Okay, so unless and until we got an element, or we are not getting an element that user want to find, so up to that we have to search the array, and once it get found, then we your searching algorithm will get stopped. Okay, it works by comparing the middle item of the array with our target. If it matches, it returns true. Otherwise, if the middle term is greater than the target, the search is performed in the left sub array only. Okay, so if your targeted element is found, then it returns true. Okay, otherwise if the middle term is greater than the target, means what, because we are already sorting the elements, and if your middle element is greater than the element to be sorted, then the search is performed in the left sub array. It is same as like your data structure searching algorithm. If the middle term is less than the target, the search is performed on the right subarray. So if the middle term is less than the target, then the search is applied on the right subarray. The syntax for the searching element is binary search in bracket start address, end address, and value to find. So what we have to do here is that, so we have to just mention what is your start address of the array, end address of the array, and which element you have to find. So that value we have to mention over here. So that is the syntax for the searching of the element. Okay, so let's see one example for the searching also. So I'll take new file again. Okay, again hash include IO stream. Then hash include algorithm, because it is an again example for the your algorithm component. So algorithm we have to include. Okay, again, suppose first what I will do, I'll write the function for searching the element. So void show, in that I will write, I'll take array integer a and size of the array integer array size. I'm writing this function just to show the elements of the array after searching it, so that as like sorting, we should not be there should not be multiple declaration of any array or any function. So that's why I'm writing here integer I is equals to 0, then I is less than array size and I plus plus. C out a of I. So whenever we want to show the elements of the array, we will just call this function now. Okay, there is no need to write this code again. Now we'll take main first, integer main. In that, as usual, we have to take array first, integer a is equals to declare some variable, some elements here, 1 6 7 3 5 45 7 8 9 and 10. So I have declared the 10 elements over here, so it should be there integer a. Now what we have to do first is, we have to first, as size is not there, okay, first what we have to do, we have to calculate the size. Okay, so what I will do for that, we will use size of operator. So in a size variable, will store or we will calculate the size of the array. So size of a divided by size of size of a of 0. So in this way we can calculate the size of the array. Okay, now what we will do, we will first display your array elements. So your array is, now we have already written the program to show the elements, so just we have to call this array, sorry, this function a and a size, the whole size of the array will get mentioned, because here we have mentioned integer array size, so that much array will get displayed over here. Now as I told you before, searching the element, we have to sort the element. Okay, so sort function, first we have to apply. So here what we have to do, sort in bracket, we have to mention a comma a plus a size, because in a size we have stored your array. Okay, array size, so that we have to write. So now see out again, sorting after sorting show in bracket a comma a size. Now we will start the searching of the element. So suppose if from the array, suppose I want to search the element as 45, which is present in the array. Okay, so what we will do, I'll just display the message as find 45. Okay, or finding 45. I will display the message finding 45. Now we have to um, write the we have to write the syntax for the 45. So what how the searching element is working, I have already told that if the element is found, then it will return true. Okay, otherwise it will display the message as element is not present. So what I will do, so I'll write the function as a binary search in, so if binary search in bracket. Now what is the syntax for that is start address, end address, and which element you want to find, that we have to mention over here. So our start address is a, our end address is a plus 10, and I want to find 45 elements, so that we have to mention over here. So if the search is successful, then it will display the message as a element found. Okay, otherwise else it will display the message as a cout not found. Okay, so it is very simple. So here if search is over, now suppose again I want to find some element, so again I will use same as a binary search in bracket a comma a plus 10. Now suppose I want to find 99, so this element is not present over here, so it has to display the message as a not found. Okay, so same element found else not found. Okay, so our program is over, return 0. So see what we have done over here. First I have written simple common function to display the elements of the array, so that it should not, we should not write this function again and again. Then what we have done, in main I have just declared first some elements over here, then I have calculated the size of the array, then your array is displayed over here. Then before doing the search operation, we have to sort the elements, that's why I have used the sort function as a sort, and in bracket start address and end address is mentioned. Then here I have just displayed the elements of the array. Then what element, the element which you have to find, that I have written in binary search function, binary search, then the start address, end address, and the elements to be found, that I have mentioned. Same here I have repeated. So see, first compile. Yeah, using namespace std is missing. So compiling is over. Now run the program. Okay, so first it has displayed the array element, then sorting elements the message, then after sorting the elements are then finding 45. So first element it is found, and after that it has displayed the message as a not found. Let me give first int l so that you will get understood. Int l after sorting finding 45 here also int l. Okay, element found again int l. After that we are finding the element as a 99, so finding 99. Okay, now let's execute, compile and run. Now you can see first the array elements are displayed over here. So after sorting the elements are displayed, then first it is finding 45. So element is found because it is present in the array, then finding 99, so it is not present in the array, so it has displayed the message as a not found. Okay, so this is nothing but the how to use the binary search to search a element in a given array. So that is the second example of the algorithm component from the STL. Okay, all examples, sorry, or all the syntax or all the functions are inbuilt function. We have to just use the syntax for the particular function, and then your work will be done without writing any code for the searching sorting elements likewise. Okay, now let's see the next component of the STL. Next component is the containers. Okay, so containers or container classes store the objects and the data. So containers are used to store the objects and data in it. There are certain types of the containers. First one is the sequence container, then container adapters, and third one is the associative container. So these are some of the examples for the containers. First one is the sequence container. So it implements data structures, or it is used to implement the data structure which can be accessed in a sequential manner. Okay, for example vector, list, dq, array, forward list. So these all are the examples for which the elements are arranged in a sequential manner. So for such type of the element, these sequence containers are used. The second type of the container is container adapters, which provide a different interface for sequential containers. Okay, so for example queue, priority queue, stack. So these are the container adapters. And third one is the associative containers. So associative containers, it implements the sorted data structures that can be quickly searched. For example set, multi-set, map, and multi-map. So all these are the examples of the containers. Okay, so containers are nothing but which are used to store the object and the data within it. So these are the use of the containers. Okay, so these all types are the according to the functionality of the particular element. So for example vector. So vector, in the vector we are having the elements which are arranged in a sequential manner, so it comes in a sequence container. Then queue, in queue we are having the again a sequential containers are used for, but for the queue we have to use the interface, so that's why it contains in a container adapter. So according to the behavior of the element, these parts are made. Okay, so first we will see some of the example from which you will get understood. So first is the vector. So vector are the same as a dynamic array elements, same as dynamic arrays, with the ability to resize itself automatically when the element is inserted or deleted, with their storage being handled automatically. automatically by the container. Okay, so vectors are same as like a dynamic arrays, which are having the ability to resize it automatically. So whenever we are having the elements in a vector, and suppose we want to insert the new element, so the size of the vector is get automatically handled by the vector itself. And suppose we have deleted some elements from the vector, then also the size is get automatically handled by the vector itself. So that is nothing but the vector. So vector elements are placed in contiguous storage so that they can be accessed and traversed using iterators. So contiguous storage, it is nothing but the continuous order. In the vectors, data is inserted at the end. Insertion at the end takes differential time, as sometimes there may be need of extending the array. So insertion of the data elements, it is always done from the or at the end only. So that is the nothing but the vector. So let's see one example for the vector, how to write the vector and execute the elements of a vector, so that you can get understood. So I'll copy this file because we are requiring it many times. So Control C, new source file. Okay, now first what we will do, first take we will take main, integer main. In main, first we will create a vector to store the integer values. The syntax for this is vector, then I want to create a vector for the integer, and for this I will create one variable as a VEC. So it has created the vector for the integer values. So whenever we want to access the elements of a vector, we will use the variable as a VEC. Okay, then I'll require one more variable as integer I. We are just doing the simple program to show the elements of the vector by using the syntax of a vector or the functions of a vector. Okay, then next is what we will do. We will do, or we will first display the size of a vector, or the display the size of the vector. So for that I'll just use the message cout, then cout, I will declare the message as a vector size is equals to. Okay, there are inbuilt functions available in the vector which get automatically executed. Now suppose I want to show the size of the vector, so there is a function that is, the name of the function is vector size. So it will display you the size of the vector. So vec dot size, so that function will display the size of the vector over here. Okay, now suppose I want to show some elements into the vector. So that is nothing but this, I want to push some values into the vector. Okay, so there is again one function. For example, I'll write first I is equals to 0, I is less than, suppose I want to display the 10 elements, and I plus plus. Okay, in that we will use the function, the name of the function is push back. Okay, so this will push all the elements in a your vector. Okay, so it will push the 10 elements which we have declared in a for loop in your vector. So vec dot push back, so push back is a name of the function which is used to push all the elements in your vector. Okay, so that is the next function used in a vector. Then suppose uh, I want to display this, we will display the size of the vector first after pushing the element. What is the size of the vector? Okay, so same function we will use, vector size is equals to, the name function is vec dot size, that is the name of the function. Okay, after that what we will do, suppose we will access the values from the vector. that is that we want to use some values from the vector. So what we will do, first we will take a for loop for I is equals to 0, then I is less than 10 and I plus plus. In that what we will do, see out, okay, vector values are VEC of I. So it will display, or we can access the values of the vector. Okay, so then so these are some of the functions, that is to push the elements or to store the elements, then how to take the size of the vector. So these are some of the functions we have used. Let me first use int L over here also, int L. Now see, now here instead of algorithm we have to include the file as a vector, because we are executing the example of a vector. So we have to include the file of as a vector, hash include vector. Okay, so it is get compiled. Now run. So you can see first vector size is 0. Okay, because we have not pushed any element before for this, so that's why it is getting the size as a 0. Then vector size is 10. After that vector values are 0 to 10, it is getting displayed, sorry, 0 to 9, so that is getting displayed. So after pushing the values, the sizes get automatically increased, and as there was no element in the vector before pushing the elements, the size was, it was displaying as a 0. So that is the use, that the size is get automatically adjusted by the vector itself. Okay, so that is nothing but the example of a container vector. I hope you get understood. So what we have done in main, I have just first declared the vector. The syntax is vector, then of which type of vector we want to declare, that we have to mention, for example integer values. Then I have just generated one variable to use the vector, that is nothing but the VEC. Okay, then there are inbuilt functions, I have just used all that functions. So size is used to display the size of the vector. Here it is displaying the size as a 0, because here we have not pushed any value in our vector. After that we have just inserted some of the elements into the vector. So as I told you, vector contains the elements in a sequential manner, so it is getting contain the elements from 0 to 9. So vec dot pushback, pushback is a function which is used to push the elements in a vector. Then again after pushing the elements, it is showing the size as a 10, that is nothing but the 0 to 9 elements it is getting displayed. And after that we have just displayed the elements of a vector. Okay, so that is nothing but the example of a vector. Now the next point in this is queue. Okay, so queue is again the example for the containers only. So queues are the type of the container adapters which operate in a first in first out type of the arrangement. Okay, so the logic is same which you have studied in the data structure. So queue is nothing but the first in first order data structure. So these elements are inserted at the back and these are deleted from the front in case of the queue. Now let's see the example for the queue in this. So we will create one more file over here, file new, and or otherwise it is better that I will show you the program which I have done already. I have done already. The name of the program is STLQ. Yeah, here it is. Okay, so let's see the program. So hash include iostream, then I have included one more file as a hash include q. Okay, then again the same function I have used to show the q elements, so that it should not be called again and again. So show q, in that q is declared as same like a vector only q, and suppose I want to use the integer elements g, so that we have done is equals to gq. So this reference is made. So when q is empty, then see out, it will show the front and pop the elements, or when it is not empty, it will show the front and it will pop the element, and it will again show the all the elements available in the queue. Now here in main, what we have done, q integer, then x, same as like a vector, so it will be of q of integer type, and x will be the variable used to, or reference used for a queue. Again queue is having the inbuilt function to push the elements, or to show the size of the size of the queue, or to show which is the front element, which elements are popped out. So all these are done, or all the functions are available in queue itself. So x dot push 10, push 30, sorry 20, and push 30. So it will push these 10, 20, and 30 elements in your queue. So these three elements are pushed or inserted in your queue. Now the queue size is again the show queue is, so it will display the elements by using the function show queue, which we have already written. Okay, now suppose I want to show the size of the queue. So again size function is used. So see out size is equals to x dot size. So this is the function which is used to show the size of the elements. Okay, then suppose I want to display the element which is available at the front in a queue. So x dot front is the function which is used to show the elements of the front. Then suppose I want to show the element of a back, so x dot back it is used. Now suppose we want to do the we want to perform the popping operation, so we will just perform x dot pop. So it will pop the element, and it again it will display the remaining elements from the queue after popping. So obviously pop operation, it will, for the pop operation it will pop the first element only, or of the top element only, and again it will display the remaining elements from the queue. Okay, so that is the simple program for the queue. All the functions we are using, all these functions are inbuilt function. We have not written a single line of code for this function, so remember it. So whatever operation you want to perform on a particular data structure, that we can just do by using or by calling these operations only. Okay, or these functions only. So run. So you can see the queue size is, or the queue element are 10, 20, and 30. So these are the three elements. Okay, then size of the queue is 3, because three elements are available. Then front element is 10, back element is 30, and after popping 10 element will be popped out, and 20 and 30 will be the remaining elements from your queue. So that is the simple program for displaying the elements from a queue. Okay, so queue size, queue front, then back, then pop, these are the operations which we have used in this program. Okay, simple program we have done. Now next after queue, so queue Victor and Q, these all comes under the part, or under the component as a container. Okay, and for that we have included the files as a vector, then file as a queue for all these data structures, separate data structure. Then next is the functions in the STL. The STL includes the classes that overload the function call operators. Also already we have seen these functions type. So for the queue we are using the size function, or to know the size of the queue, then pushback function. So all these are the functions which are included in the STL library. The instances of such classes are called as the function object or the functors. Okay, so whatever instances we have used, for example in case of the vector we have used VEC as an instance, or in case of the q I have used x as an instance, so that is called as the function object or the functors. Okay, it is, the name is the functors, not the functions. Okay, functors. So functors allow the working of the associated function to be customized with the help of the parameters to be passed. So all these functions we have already seen, so I have not taken any separate example for it. Now next is the iterators. Okay, iterators are, as the name suggests, iterators are used for working upon the sequence of the values. For example vectors, so when we want to access, or we want to use the values of the vector, we have to use the iterators only. Okay, so these are the major features that allow generality in a STL, that is standard template library. So let's see an example for the iterator. I'll show you an example for the same. Okay, so again open iterator example. Yeah, still iterator. Okay, it is very simple. So I have used for the simple iterator, sorry, vector only. So iostream.h, then I have included iterator file and vector file. Okay, because we are going to vector to show the use of the iterator. Okay, I have declared vector over here of integer type vector. Integer ar is equals to 1 to 5 elements I have declared. Then declaring iterator for a vector. Okay, so vector integer iterator pointer. So this is the syntax for declaring iterator for any particular uh, what we can say example. For example, suppose I want to create an iterator for q. So what I will do, instead of vector here, we will write as a q, and which type of q we want to generate, so that we have to mention over here. Now suppose we want to display the elements of a vector. Okay, using begin and end. Begin and end, these are the functions which are associated with the iterators. Okay, so see out the vector elements are, so ptr is a reference or the instance of the iterator. So ptr is equals to in ar dot begin, then less than ar dot end, and ptr plus plus plus. So ar is nothing but your array. Okay, so from begin to end it will display all the elements, so that is nothing but the iterators. Okay, so see. Okay, so elements are 1 2 3 4 5. It is very simple. So iterators are just to use or to display the elements of a particular type or particular STL library. So that is the use of the iterators. Okay, so here we have completed our 8th unit, that is nothing but the standard template library. So in short, it just contains some of the functions, inbuilt functions we have to use. So if you are aware, or if you have studied about the template in detail, then only you can understood the use of the STL. So first study the template chapter, then you will get understood all the parts related with the STL. Okay, so thank you.